Okay, I'll say it again. You don't have to answer, somebody else can. So the question is, on that Nearpod slide, that cylinder, it has a diameter of 6. The formula for area of a circle is radius, which is half of the diameter, but it's radius squared times pi. Why not just put the radius back? I mean, if you got to square it, why would it not be 6 like the diameter?
Because when you square, you have to multiply it by itself. So
yeah, it's not times 2, so it'd be times 3, right?
Mm-hmm.
So in that Nearpod drawing, it would be 9, that's 3 squared, times pi, which is going to be 28-ish, times the height, which I think was 5. And so 28 times 5, so you should have a number in the 130 to 50-ish range, right? Somewhere in that range for the volume. I see a 141 cubic units. So yeah, so you'd be looking for something in that range. So it would be square the radius, which is half of the diameter. So you half the diameter, get that number, square it, which would be its times itself, not double. Let Madeline in. All right. And then from there, you would multiply it by pi, as I said, and then you multiply that times the height, right? Yeah. Okay, let me let Lincoln back in. Apparently he popped out. All right. So on today's Pear Deck slide, I'm going to go ahead and move it through. You can just pause. I mean, we're not going to answer all these again. Quickly, this slide yesterday we talked about simply is showing you that with all the volume that you're doing, whether it's a prism, whether it's a pyramid, whether it's a cylinder, whether it's a sphere or a cone, we're going to come back to cones and spheres, but I'm going to go ahead and talk about surface area a little bit first. The next couple days, and then we'll swing back to those. It's about getting the bottom layer of cubes and then how many floors there are up. So it's always about the base of the deal, whatever the solid is, times how tall it is in some form. All right. Remember yesterday we talked about volume can be tricky. Could someone, no, tell you what, respond on that slide and tell me on your Pear Deck what has to be considered in deciding which of those holds more volume. Because we all made arguments about all 3 of them yesterday, but we were only thinking about height. What else has to be considered about thinking about the volume? Because it can be tricky when you're looking at, say those are 3 cups at a restaurant and you want the one that would have the most beverage in it, most of your favorite drink. So if you'll respond on there and tell me, besides how tall it is, what else do you have to consider when you're thinking about its volume? Let Liam in. If you just got in, welcome. And the code for the Pear Deck is ROXBN. ROXBN. So, let me give you all just a second if you've not answered. Remember, keep yourself on mute when you're talking so it doesn't give us feedback if you can, please. All right, from the people who have answered, Michaela, you have a great response. Michaela said, I quote, "We have to consider the width of the cup because it could be possibly holding more than the taller one." What do you mean by that, Michaela?
I know that sometimes when I go downstairs to my kitchen and I get a drink, I know that sometimes we have shorter cups, but it's very wide. And so it holds more than our cups that are taller than the wide one.
Okay, you all recognize that I'm holding a familiar especially if you're in lunch bunch, this should be familiar, right?
Um,
Okay, this is a mug, right?
Very.
See this mug? That my Superman mug. You're like, oh, you remember to bring it home. No, I have one at home and one at school. I have two. All right. So this holds a lot more coffee than you might think. All right. So let me hang on just a second. My prop's not here. Oh, wait, here it is. Okay. So here's a Jason's Deli cup that you get Jason's Deli from back when you could go in a restaurant. Well, you can take out. All right. Everybody would go, oh, I want that Jason's Deli cup, right? Because you're like, that's going to hold more drink. No, if I pour this Jason's Deli into this, there'd still be room in this mug. Because it's not just about this literal height. Let me put it right here. It's not literally about the height. It's about their base. Look at the base.
Yeah.
See the base?
So
now here's another thing stores do. Okay, you see the bottom of that, right? But this is not a true cylinder, is it? Because look at the Superman mug. There's the bottom. There's the top. The circles are the same. I know it's hard to see. The circles are the same. But look at the Jason's Deli. See the bottom? Look at the top. That's not a true cylinder, is it? Because it gets bigger, right? So they do that a little bit to make it look like it's more than it is. So Michaela, you were right, and Fred, you're going to say something because I saw your hand was up. Let me say this, that it's about considering the area of the base and the height, because the height alone will not determine the bigger volume. Because remember, you're multiplying all the layers up. But think about it. If you're multiplying 5 layers up, but on the bottom layer, you've got 25 versus you've got 100. That's gonna be a lot more volume really quickly, right? Fred.
I think that they're all the same.
You know, there would be a way to talk about that where they are all the same. And actually, what would be a really cool activity is to come up with what measure would I give each one of them to make them be the same. That would be kind of a fun task to do. But yeah, they could all be the same, but they don't look the same. But it can be tricky because it's about the volume being the base times how tall it is. So it's about that circle base. All right, let's look at the next picture. Just a quick reminder, nothing to write. Remember, this is a cylinder just like this is a cylinder. It's just this cylinder that is commonly used is a right cylinder because it has a perpendicular side to it, right? Because the side here literally is a right angle to the base, right? So it literally makes the right angle. Y'all see my little right angle there? Whereas on this one, I would get it, but I would have to over here and do the height this way, right? Not this. Okay, I'm getting feedback. All right, so yeah. All right, moving on. So will you tell me on your slide, what is the volume if the height is 7 and the radius, and radius is a little r, is 2. What is the volume? They brought that up. Yep. Okay, I'm getting very different responses. Okay. Would somebody volunteer to tell us how to get the volume of this?
I can.
Thank you.
So you said the radius was 2.
Yes.
So 2 times 2 is 4.
Okay, why?
Then, because it's r squared.
Right. Yep.
4, and then you have to do 4 times 3.1.
Oh, sorry. Hang on. Just a second. Okay. So 2 times 2 equals 4 times 3.14. Okay, my fingers are hitting all the wrong buttons. Okay. And then what do you get from there?
12.56.
Yep, 12.56. You
Then
can
you
do
have to-
that one with distributed property pretty easily. All right, then what do you do with that?
12.56 times 7
Yep.
is 392 cubic units. That's what I got.
Okay, so let me think about it. Does 12 times 7 seem like 300? Because what's 12 times 7? 84?
It's 84.
Yes.
So shouldn't it be something around that? Kayla, will you do 12.56 times 7 again? Please.
I calculated that wrong. It's
Yeah.
87.92.
Yeah. Yep, that's right. So, by the way, earlier I was making that Nearpod lesson for you to do in the morning, and Dr. Parsons was looking on my shoulder, and she goes, "Where did you get that number?" And of course, I goofed up because I was calculating something wrong, and I'm glad she caught it because you'd been like, "Tomorrow, it doesn't make any sense." All right, yeah. So that's what you would have done there. Several of you got 87.96. If you did not get 87.96, do you see why it should be 87.96? Okay, if somebody's laughing and being silly, will you hang on, please? Because I think somebody is. And remember, if I don't know what measure it is, I just call it units, right? Okay, so my phone's off. Let me go back here. Okay, here's the next one. All right, why do you think this one will be easier? I think I said this yesterday. Why should this one be easier? Could someone tell me why this might be easier? Let me hear. Go ahead.
It might be easier because the height is 10 and 10.
Yep. Because those are not hard numbers, right? You got it right, Kimani. That's right. All right. So go ahead and send me the volume of that. The volume would be the radius squared. So that's 3 times 2 is 6, right?
3 times 3.
Yeah. 3 times 3 is 9 times pi. And then that times 10. Okay, I'm getting a lot of people with a number that is the same. So I bet that must be right. If you haven't sent it on your Nearpod yet, on your Pear Deck yet, if you will, if it's not working for you, just text it to me, please. Thank you. Fred, did you get my text?
Mm-hmm.
Okay. Was that what you wanted to know?
Mm-hmm.
Okay. Thank you. And just think, guys, all the iPads I have at school, I don't have any iPad here to use. So I don't have a split screen. I have to use my phone and keep going back and forth. That's kind of ironic that I don't have an iPad to use. All right. So could Madeline and Betty, could you all together just tell me what you got? So if one of you would go first and then the other one, just tell us what number you got. So let me ask you, you can say yes or no. Did you do 3 times 3 is 9 times pi, 3.14, and then that number was 28.26, and then you did that times 10? Is that yes?
No.
No.
I got to multiply it times pi.
Okay, but you have that answer. I think you did because you have the answer.
Well, I just did 3. I just did 3 times 3 because
Yeah.
it's squared, and then I did that 9 times 10 divided by 3.
Because you got 282.6.
No, I didn't. I got 30.
Oh, sorry, Betty. My bad, because I see that these are tricky. That's somebody else's. That's Kylie's. Because you
Okay.
were above her, I forget that it's the thing pointing to the person. Okay. All right. Do you see why it would be, though, Betty? 3 times 3 is 9.
Yes.
And then that times pi would give me the area of the base times 10. Madeline, do you agree?
Yes.
All right. So, yeah. All right. So, if you didn't get, I think everybody else did. And Betty, you see why it's that, right? Betty?
Yes.
Okay. All right, good. All right, we have 10 minutes left. Okay, so this one would be harder, correct? So would I have a volunteer to save some time that would go ahead? Remember, don't annotate on the screen unless you're doing something for the group, right? That's to the lesson. Would someone tell me what is the area of the base for this? Or how would I do it? I'd do what? You agree it's 17 and a half times 17 and a half? Why is it 17 and a half times 17 and a half times 3.14? Oh, that feedback. Let me ask somebody. Help me out, please. Josie. Why is it 17 and a half times 17 and a half? Where did I get that from?
Because the algorithm is pi times radius squared,
Yeah.
and 34 is the diameter, and so you have to have 34.
Okay.
And then you do.
That's right. Does somebody have a reliable calculator that could give us that answer? I can't get to mine because
I got one.
Thank you.
The answer would be 25,963.75.
Somebody else verify that looks right. So it's 17 times 17 times 3, basically.
It's 875, not just 75.
Is it 34 divided by 17?
Mr. P, it wouldn't be 17.5, it would just be 17.
Yeah.
Oh, my bad. You're right. They're looking at that at 35. Okay. So could somebody, Kimani, will you recalculate that? Thank you. Could somebody tell me what you get for that?
Um, 17 times 17 is 289.
Okay, and then 289 times 3.14?
Okay. I got the final answer.
What'd you get?
I got 24,501.42.
Okay, so let's say that's the area of the base. Will you text me now what would be the volume of that cylinder if that's the area of the base?
Hey, Kiwi, could you repeat the base?
24,501.
No, that's not the base. That's the whole thing. I didn't
Okay, so
account the specific base. No, the base.
all right. So backing it up. Okay, the correct area of the base is 907.46. Okay, and then you'll multiply that times the height, which is 27, right? And then that's where you get the 24,000, right, Kimani?
Yeah.
Okay, so I'm just going to move us on because he already gave us the answer, right? So there's the answer. All right. Yeah, that's the answer right there. Okay, moving on to the next one, but I got to move my phone off of this back here. All right, which a lot of you got that. Okay, so next, I think we got time for two more. All right. Again, here we want to do 25 times 25. So I'm going to quickly give you the area of the base. All right, so the area of the base is, type it right here. Okay, the base's area is 1,962 and 5/10. What's the volume of the whole thing?
What's the area of the base again?
1,962 and 5/10.
Oh, I think so.
If you'll send me what the volume of the whole deal would be then. So it'd be 1,962.5 times 40. And when you multiply that together, you're going to get. Dada. Hello. I have a volunteer can quickly tell us. We only have 5 minutes left. Thank you.
78,500.
That's exactly right, because you said 40 times 1962.5, right?
Yes.
Yeah, that's correct. All right. Next one we have. All right. So with this one, which one of those is not a necessary measure that we don't need? Could somebody tell me really quickly which of those measures we don't need?
The 2 millimeters.
Right. The 2 millimeter is if we wanted to figure out the circle inside, the cylinder inside the, like pretend like that's a thermos, and that outer layer is the, if you've got a Yeti mug or something, and it's you hold it, but what holds in there is a thinner, a smaller cylinder, right? Because there's a vacuum seal of space of a vacuum around it. So that would be like getting the volume of the inside container there. So we need the 125 millimeters. What do we need with the 184 millimeters? What needs to be done with that? Half? Yep, half. So what's half of 184? We need that. And then once you get that, multiply that times itself, times pi, times 125. So you're going to have a really big number this time. So I'll give you the start. Okay, 184 divided by 2
It's 9.
is 92. 92 times 92.
8,464.
8,464 times pi. So the area of the base, I'm writing it on here, is this. 26,576.96. And here's the thing that's going to happen to you in 7th grade. You're going to get problems with bigger numbers you have to deal with like this. So that way, they're not going to have a unit on decimals and all the algorithms. They're going to be giving you problems where you have to do that in the problem. So be sure that you're paying attention to your arithmetic, okay? Now, what did I do with that 26,576 and 9600ths number? I multiply it times 125. So let me give you a second to draw on your slide and tell me what would the volume be.
She's got to run.
Hey, Mason, not to distract, but it's funny because I see your face and then I see your brother's back, and then his face is right under that in his slide. So we got 2 views.
Yeah.
Yeah. All right. Did you get 3,322,120 cubic millimeters?
Yes.
Yes. So the answer is that. All right. So the base again is 26,000 something, and then outside that we've got the height 125, and then that's the 3 million whatever number. But again, remember, that's not a really super big thing because millimeters are really, really, really tiny, right? Like a millimeter would be less than the thickness of your thumbnail, your fingernail, right? That's like a millimeter. It's like the thickness of your fingernail. All right. So yeah. All right. So we're gonna stop there for today. Does anybody have a question or a need of something? Be sure that you do the Nearpod.
Galaxy.
Yep. What, Kimani?
Look at my galaxy hair.
Your dog's ear?
No, my galaxy hair on the thing.
Oh, your galaxy hair. I see it. Yep.
Hey, Mr.
Oh.
PR, we're doing a game kit today?
Yes, I was about to say we're going to do a GIM kit in just a second, so I'll close this out and open that up. Please stay with us. And then also, don't forget, it's important that you do the Nearpod lesson in the morning that it's me in it. It's not just a random person, because that will take the place of prepping for the lesson tomorrow. That's the prep for tomorrow's lesson, okay? So I'll close this out and I'll open up the GIM kit and the Zoom for that in just a second. Oh, quick reminder. You can go on flyparsons.info, on the website anywhere, click on the class calendar, and each day the link to come into the Zoom is going to be there. So you can go ahead and get yourself in before 11 if you want to click on it. It won't let you in, but you'll be ready. So it's there. I've got it reoccurring every day until the end of the year. All right. So I'll see y'all over on the.
Bye, everyone, look at me. My true form. This is my.
I'll tell you what.